right, first graders, let's do our math lesson for today. Today's math lesson is going to be more about shapes. You are going to need your math notebook or whatever paper you've been using for documenting our math problems that we solve together. And you're going to need a pencil. You don't need your math journal today. You don't need anything else. So after you get that notebook, then let's get started. So let's do a math warm-up together. We are going to solve number stories again for this math warm-up. So please turn to the next clean page. And here is the first question. Kim has 16 feathers. He gives some away. Now he has 8 feathers. How many feathers did Kim give away? So Kim started with 16 feathers. He gave some feathers away, but we don't know how many. And we know he ended up with 8 feathers. So we're trying to figure out how many feathers did Kim give away? That number sentence would look like this. Your job is to figure out what that missing number would be. And then also we're going to label that number story with the word feathers because that's the thing that Kim was collecting. Go ahead and figure out what that missing number could be. The second one says, Jack has 10 sticks. He loses some sticks and now he has 8 sticks. How many sticks did Jack lose? So Jack has 10 sticks. He loses some of them. We don't know how many. But now he has 8 sticks. How many sticks did he lose? We're trying to figure out the missing number in a subtraction sentence again. Remember, you can think addition to solve the subtraction sentence. You can turn it around and pretend like it's in a fact family. You can count up or count back. But if you're trying to solve 10 minus blank equals 8, what would go in that blank? All right, the last one says, Tanya has 15 beads. She used some beads to make a necklace. Now she has 7 beads. How many beads did Tanya use in her necklace? All right. So if we know she had 15 beads to start with, she used some of the beads to make a necklace, but we don't know how many. Now she has 7 beads. How many beads did Tanya use in her necklace? So again, we'll use the same strategies. We can use think addition, we can count up, count back, we can pretend like it's in a fact family and flip it around so that we're thinking addition. And we're also going to label with the word of that comes from the story, which is beads. All right, after you've solved all 3 of those problems, we are going to flip to the next clean page in our math journal. And I want you to draw 2 shapes. So here's the shapes you're going to be drawing. One of them is a triangle. So just like this, draw a triangle on your page. The other one will be kind of like a triangle, but let me show you an example of what it will look like. The other one is a triangle that's open at the top. So it's not going to have that pointy part at the top, just open. All right, so you've drawn those 2 shapes in your math notebook. I want you to look at those shapes. How are they the same? Take a second and think. How are those 2 shapes the same? How are those 2 shapes different? Take a moment and look at them. Okay, hopefully you have an idea of at least one way they are the same and one way that they're different. One way that these shapes are the same is that they both have 3 sides, right? They're not exactly both triangles, but they do both have 3 sides. One way that they're different is that this one is closed and this one is not closed. That's what makes it not really a triangle. Almost a triangle, but not exactly a triangle because it's not closed at the top. Today we're going to be learning a couple new words in our math lesson. These words are defining and non-defining attributes. Oh my goodness, those sound really, really big, don't they? Well, today we're going to talk about what makes a shape that shape and what that shape doesn't need in order to be that shape. Okay, let's take a look at these three triangles. These are all triangles, right? They're facing different directions. They have, like, one of them has a pattern on it. Their sides are not all the same length, but we could say that they are all triangles. The thing that makes them triangles is that they all have three sides. They have three vertices, which are the corners where the two lines meet. And they have straight sides, because we know that triangles have straight sides. They don't have curvy sides. And they're all closed, not like that triangle, that almost triangle on that last page that we drew. This wasn't really a triangle technically because it's not closed. But there are also things about these shapes that make them different, right? Those are called the non-defining attributes. That means you might see these things on some triangles, but they don't need that to be a triangle. For example, this one has spots all over it. It's a triangle, but the non-defining attribute that's on there is the fact that it has spots. That's showing something that has nothing to do with the fact that it's a triangle. This triangle has a corner that's called a right angle. That means the two lines meet here and make an edge, or sorry, they make a corner that kind of looks like the corner of a square. Triangles don't need that to be triangles. This one just happens to have that. These triangles are different sizes. They're facing different directions. Those are non-defining attributes. That means those triangles don't need those things to be triangles. The defining attributes are what we said before. A defining attribute means that every triangle has those things. So we said every triangle has to have three sides. Every triangle has to have straight sides. Every triangle has to have three vertices or corners. And every triangle has to be closed. All of the sides have to meet up. You can't have that open end like we had on that last page. The things that make these triangles are defining attributes. Okay, I'd like you to open up your math notebook to show that you have two clean pages next to each other. We're going to use one of the pages for drawing some shapes, and one of the pages is going to show a chart that we'll make about those shapes. Okay, on the first page, I want you to draw three rectangles. Now remember, a rectangle is a shape that has two long sides and two shorter sides. The rectangle can be any size, but it has to show two long sides and two shorter sides. All the sides have to be straight. You're going to draw three rectangles. They can be any size. You can put any kind of design that you want inside of them, but they all have to be rectangles, and they all have to have straight sides, two long, two short. Go ahead and do that now. Okay, I drew 3 rectangles too. I have a smaller one that has nothing inside. I have a really big one that has dots inside. And then I have one that's even facing a different direction. It's kind of like standing up, and that's got some squiggly lines on the inside. Now on the other side of your 2 pieces of paper that are next to each other, you're going to make a chart. Here's what we're going to do first. Let's draw a line down the middle because we need 2 sides of this chart. On the first side, you're going to write the word defining. I'm going to show you how to spell that right now. Defining. D-E-F-I-N-I-N-G. Defining. We're going to put defining attributes of those shapes on this side. Before we do that though, let's label the other side. The other side will say non-defining. That's the opposite of defining. Okay, so that's going to be a little bit longer. You're going to need to give yourself a little bit more space. All right, now we're going to write down some things on this chart to show that we know what makes a rectangle and what we see on those rectangles that doesn't really matter for making them a rectangle. Okay, on the defining side, what can we say about these rectangles that makes them the same? Every single rectangle in the whole world will have these attributes. So think, what makes a rectangle a rectangle? Well, they have 4 sides, right? So I'm going to put a little dot there to show that I'm going to separate this from other lines, from other words on the page. So they have 4 sides. Another thing that makes a rectangle is that they have 4 vertices or corners. Now, if you don't spell these words exactly right, that is okay. You try your best. But we can put that there are 4 corners on every rectangle. Another thing that I notice that rectangles have is that they all have square corners. That means corners that are different than these triangle corners, because these triangle corners don't make the corner of a square when you draw them because the angle is different. Rectangles have 4 square corners, so we can write that down too. Four square corners. Now, the non-defining attributes of these rectangles are things that don't really matter for making them rectangles. For example, my rectangles have different patterns on them. That doesn't really matter for making it a rectangle. The pattern has nothing to do with the fact that it's a rectangle. That means it's a non-defining attribute. That means it doesn't define the shape. It doesn't make that shape that shape. So on my non-defining side, I can write different patterns. And again, you don't have to spell all of these words correctly. Try your best with the spelling. I just wrote 2 words, different patterns. Another thing I notice about my rectangles is that they're not all facing the same way. So that means they're facing different directions. Again, do not worry about spelling, just try your best, but I'm writing facing different directions. Another thing I notice about these rectangles is that they're not all the same size. I drew my rectangles to be different sizes, and I hope you did too. We can write different sizes. It doesn't matter what size a rectangle is to make it a rectangle. We talked before about finding shapes in our houses. I said I have a door right behind me that's a giant rectangle. It's still a rectangle, just like this whiteboard is a rectangle that's much smaller, or a piece of paper is a rectangle, it's much smaller. They're all still rectangles. It doesn't matter what size they are. And another thing that I didn't do, but maybe you did, was make the shapes different colors. So if you have different colors on your rectangle, then those are non-defining attributes. The color of the rectangle does not matter for whether that shape is a rectangle or not, right? So a defining attribute is what you see that is always going to be the same. When we wrote these defining attributes of rectangles, these rules right here apply for every single rectangle that you'll ever see anytime in the whole world. A non-defining attribute is what you see that can change. Patterns, shape, size, color. Those things don't really matter for making the shape a rectangle. They do not define the shape. I put a helpful little chart in the email that I sent to your parents. It shows pictures of defining and non-defining attributes. And you might want to take a look at that so that you can help get a visual in your brain of what we're talking about today. This concept, defining and non-defining attributes, is going to be on our test. We won't have a test for a while, but I want you to be aware that it's coming up on the test and that you'll need to know what the difference is between defining and non-defining attributes. Look at that chart and let me know if you have any questions. You can have your parents email me. I'll see you tomorrow for another math lesson.